2008 Wenchuan-China earthquake of magnitude 7.9 by Arda, Şahin, Dr. Şahin. I think we have around 10 minutes and completed within that time.
Okay. Welcome everyone. I'm Arda Şahin, and before I start, I would like to say that I'm glad to hear, and I'm very happy to present in front of all of you. Let me introduce myself a little bit. I graduated from Middle East Technical University Civil Engineering Department, and currently I'm doing my master's degree with Professor Dr. Kemal Önder-Çetin. So we are working on gravelly soil liquefaction as my thesis topic, and during my studies I came across with a case history that has one of the biggest data set for gravelly soil liquefaction. So I just studied on it, and I want to share my findings with you. So first of all, I'm just going to give a little bit introduction about liquefaction. Most of you know all of this. However, I'm just going to give small introduction, and after that, I'm going to move on to the gravelly soil world. So let me define the liquefaction for you. All of you know this. However, it is pore pressure increase due to cyclic loadings, and with pore pressure increase, we know that shear strength and stiffness parameters decrease. The important part here that we should know that liquefaction is not a failure mechanism. It is just a reduction in shear strength and stiffness, and due to this reduction, excessive settlement or exceedance of bearing capacity might occur. So let me just elaborate on surface manifestations. How can we know a site is triggered or not? So we can observe some fissures, or like I said, excessive settlement, or lateral spreading on a flat surface. Why do I call flat surface? Because if we have a lateral spreading in a site, and if it's sloped, we know that it might occur due to a slope stability problem. So we have to know that it should be occurred on a flat surface so that a liquefaction is triggered on that site. After that, I want to say a few words what soil types are considered to be liquefied. So as we know, we have clay, silt, sand, and gravel soil types basically. And there are some parameters saying that if they are probable to liquefy or not. So we have particle size with different, like clay has small, and up to gravel, it has large particles. After that, we have to check for permeability, and with permeability, actually, its pore pressure dissipation capacity differs, and most likely, all of us think that we have low probability on clay and gravel, and we have the highest probability for sand to liquefy, and silt is between these two ends actually. Let me show you some triggering curves developed. So like we have curves for sand, and we have curves for gravels actually. This is just a spoiler might be, but we have gravelly liquefaction triggering curves. So we have checked-in Mohs, Kane, Rollins to Rollins, and Sao for curves. And the important thing is we have a site investigation method selected for each of the triggering curves actually. So what can we have? We can have STT blowout, we can have slip resistance, we can have shear wave velocity, we can have DPT or LPT. I couldn't find a triggering curve related with LPT, but you can use it in order to use for your triggering curve. So let's move on to the soil liquefaction, gravelly soil liquefaction part. So do gravelly soils really liquefy actually? So why do we think they doesn't liquefy? So we have large particle size, we have high permeability, and due to this, we have high void pressure dissipation capacity actually. So they are considered to be non-liquefied. However, we have some cases, actually a lot of cases showing that we have gravelly soil liquefaction, and from these cases, we understand that they have some probability to liquefy actually. So after this, recent studies show that we have some triggering curves, and they are using some parameters inside their triggering curve. After SAO, which one of the mostly used curve currently, Rollins is adapted moment magnitude inside to his triggering curve. So I would like to talk about a little bit of its applicability of STT and CPT. Why do we have to talk about this? As you know, we have some dimensions about CPT cone and STT sampler. CPT cone has 10 centimeters square cone, and STT has a thickness of 7.5 millimeters. And as you know, the boundary between gravel and sand is around 4.75 millimeters. What does that mean? The thickness of the STT sampler and the area of the cone might be measuring the strength of that one particle, not the whole soil layer of that one particle, which might result very high resistance. However, it might have very low resistance in the whole layers. So let me move on to the Wenchuan earthquake, which I studied. So Wenchuan earthquake is in China, and you can see the epicenter, and it occurred on May 12, 2008, with a moment magnitude of 7.9. And in 73 different locations, investigations were performed by Sao and his team, and total of 112 measurements are taken in the means of VS and PPT. So I grouped these locations into 10 different parts. I grouped them accordingly to the biggest cities in Wenchuan County, and there are some gradations curve presented by Sao. And with these grouping, I just take the average of PGA and the number of measurements to summarize it. And after this, I have a procedure to evaluate the triggering, liquefaction triggering relations, and I just want to show an illustrative case history for that. I selected Songbai village. You can see the location there, and it's 20 kilometers from Dayan city, which is one of the biggest cities there are. And here, fissures and lateral spreading is seen in the site. However, when I examined, most of the sites has not excessive settlement problems for gravels, and I just thought that might be not relevant to gravels when excessive settlements are occurred. That might raise a question actually. And in this site, VS and EPT measurements were taken. I estimated Jainer-Boer distance as 38 kilometers by using the coordinates and also the stations in the site. By using this distance, I entered to ground motion prediction equations for different researchers, and also there exists an event-specific shape map for this presented by USGS, and by using both of these, I estimated a PGA as 4.29 actually. Also for this site, there exists a gradation curve for the relevant critical layer. I will come to the critical layer part, and as you can see, the D50 value is around 6.16 millimeters, which shows that we have a higher gravel content than 50% actually. So for this procedure, I have to select some other parameters. So first, unit weight. For unit weight, I used a correlation between D50 and dry unit weight actually. And this is proposed by Chen actually, and it corrects its equation for well-graded gravels. So it is a good estimation for my sites. And I also used the proposed solution for by Çetin between SPT and dry unit rate actually. However, it should be noted that most of these dry unit rates are a little bit low for gravels because they are proposed for silt and sand soil units. For CSR, I used the simplified procedure proposed by seed emitters, and for RD selection, I used the proposed equations by Çetin and C 2004. After that, I selected my critical layer for this site. There are some important parameters that we should follow while selecting the critical layer actually. So first of all, it should be below groundwater table level, and it should be a soil unit that is probable to liquefy actually. And after that, I selected it by using the VS or DPT measurement with lowest resistance and highest CSR value. For the properties of this critical layer, I obtained these values. And by using these values and the proposed triggering curves by Rollins, I added all of my data for Wenchuan-China on these triggering curves. And as you can observe from this, since most of these sites are liquefied, DPT has a better understanding since most of the data points here is on top of the 50% probability. However, in VS triggering curves, there might be an adjustment needed for these curves. Before I finish, I would like to acknowledge that and thank to Professor Saudat for sharing his borehole logs and data gathered from the site. And I also would like to thank all of the researchers that are trying to develop liquefaction triggering curves. I would like to thank you for your kind attention. I hope to see you in another seminar soon.
As it comes, it may be until we get to the questions and answers. Now, ladies and gentlemen, we will carry on with the next presentation, which is